6. Maybe it was the 8th. But good morning. Getting things set up. Here's our first problem, right? Let's read carefully today. That's my biggest trouble with these is I don't read right. I have trouble reading things. But yeah, you were given a page today. We are not going to do all of them today. You are not going to want to do all of them today. There's a whole bunch of them on there. We are going to spend some time next week looking at them as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. My goal today was actually to get through 2 or 3 of them. So if you could try to get through 2 to 3 of them today, that would be awesome. This is number 1, so we're going to start with number 1. Again, I will walk you through some of them, but you really should be starting to at least try them on your own today. So we are looking at number 1 first. And I'll start in a couple minutes here. But go ahead and give it a shot while you're looking at it. See if you can pull out your equations, and then see if you can substitute in to solve. The first thing you need to realize is when solving this, if you didn't already, is that everything is in hours except for this. So for the other system equation plays, how would you do something like number 1? The other page is in yesterday's. I don't have that one up. Or I just give you the equations and you find the intersection point. Is that what you're asking about? And I'll let people continue working on that one. What I was saying is that if you didn't make this into hours do so. And I believe that's 5/12 of an hour. While you're giving this a shot, I'll go over number 1 on the other page with John. Because if we don't have this down, then once you get your equations, it's kind of tough. So here you have 3x plus y equals 15. And you have x plus 2y equals 10. Your first thing you want to do is solve for a variable. And what I mean by that is, you want to get one of these equations to say a variable equals something. You don't really know what that's going to be, that's something, but as long as it says like x equals this or y equals this, that's what we're going for. And in the past we've been doing y, but you're more than welcome to do x. It doesn't really matter. You'll just find y. If you solve for x, then you'll substitute in for x and you'll get your y coordinate first, and then you'll get your x coordinate second. So we want to solve for y on one of these. And just looking at it, it looks like this one here is the easiest one to do. Because all what I got to do here is subtract y from, subtract 3x from both sides. So what I'm going to do is I'm going to solve this one for y. I'm going to get this to say y equals something. So over here I'll do 3x plus y equals 15. I want to get y by itself, so let's subtract this 3x. If I do it to this side, I got to do it to that side, so this will go away. And you'll get y equals 15 minus 3x. Or now we have it set up so y equals something. Once we have that, I know wherever I see y, instead of writing y, I can write 15 minus 3x. So I will plug it into this equation here, because I have a y here. So this will read x from this equation plus from this equation 2 from this equation. Then in parentheses, because instead of writing y here, I'm going to write 15 minus 3x. Then I'm going to close my parentheses. This whole thing is being multiplied by 2. And then that's going to equal 10. Eventually we're going to do all the problems. I'm asking you to do 3 of them today. We're going to try to get through 3. And that's going to be kind of a lofty goal. But next week we'll be looking at the same problems again. So we're going to continue working on the word problem side of it. This is tricky, so I'm trying to give you a lot of practice on it, a lot of different types of problems that you can solve with it, and unfortunately it's just going to come with practice, practice, and practice. But here, once we substitute in, so our second step was to substitute. Substitute, however you spell it. And then you're going to solve for x, so then we have to solve for x in this case. And again, you're going to use your algebra tools that you know. Looking at it, you know the distributive property. 2 is going to be distributed to 15, and 2 is going to be distributed to negative 3x. So we're going to get x plus 2 times 15, which is 30, plus, well, it's going to be minus because it's negative, but plus a negative 6x, because 2 times negative 3 is negative 6, and then you have the x. And just cleaning up the signs is going to be negative, and then that's going to equal 10. You're then going to combine your like terms. So number 4 is combine like terms. You can add your x's together. So 1x, remember there's a 1 in front of here, minus 6x is going to give you negative 5x plus your 30 equals your 10. And then you're just going to solve for x here. We're going to subtract 30. Subtract 30. Just watch your sign work. You're going to get negative 5x is equal to 10 minus 30, which is negative 20. Then you're going to divide by negative 5, divide by negative 5. This will cancel, just like that did. You're going to get x equals, and then 20 divided by 5 gives you 4. If they are both negative, so that is a positive 4. Here, you're going to take this x value and plug it back into one of these to solve. If you trust yourself on the way that you converted, you could also plug back into the one that you converted. But then again, if you made a mistake converting it, it's going to show up there as well. But it would also have showed up down here. Just be double checking things, making sure whatever you're doing is making sense to do. So I'm going to go ahead and plug that back into one of these. I'm going to plug it into, I guess, this one right here. It doesn't matter which one you plug into. I'm just going to choose this one. So 5 is plugged back in. Any of the original ones, it would have worked for either of them. So I'm going to come down here. I'm going to write 3. And then instead of writing x, I know x equals 4 now. So I'm going to write 4 plus y equals 15. And now I'm going to solve for y. 3 times 4 gives me a 12 plus a y equals 15. Subtract 12 from this side to get y by itself. Got to do it to that side as well. 12s will cancel, leaves you with a y equals, and then 15 minus 12 gives you 3. So your x-coordinate is 4 and your y-coordinate is 3. So your answer is the point 4, 3. This is where they're going to intersect. So that was that. Let me switch back to our problem here because this problem is not easy. So things that we need to know here. Let's delete that. But yeah, it's going to take practice. We're going to stay on it for a while. We're not going to move off of this until we start feeling pretty comfortable about it. But it is difficult. Okay, so your aunt and uncle have been visiting your home. 5 minutes after they drive away, you realize they forgot their luggage. So they already have a 5-minute head start. So just remember that. You happen to know that they drive slowly. So you get in your car and drive to catch up with them. Your average speed is 10 miles an hour faster than their average speed. And you catch up with them in 25 minutes. How fast did you drive? So here, again, first thing you want to look at is this 25 minutes. If you didn't convert that to hours, go ahead and convert it to hours. You should remember dimensional analysis to do so. You have 25 minutes. And you want to turn that into hours. So this would be minutes on the bottom, hours on top. You know there are 60 minutes in 1 hour. This becomes 25 over 60, which will reduce down to 5 over 12. And you're more than welcome to use the decimal too. It's up to you. I think I'm going to stick with the fraction for now. So just pulling out information that we know. We know that we want to know when our two speeds are going to be equal. So we want to know when our speed, so let's say our speed, what variable do I want to use? Let's use y for our speed, or your speed, I guess, and g for grandma's speed, or grandparent's speed, whatever you want to call it. So this is going to be our speed or your speed, and this is going to be grandma's speed. We know that we want them to be where the time is going to be equal, right? We want to know, I think that's what it's asking. Your average speed is 10 miles an hour faster than their average speed. You catch up with them in 25 minutes. Yeah, so we need to know when time is going to be the same. Also, your 5 minutes up here is going to probably want that to be in hours as well, which is 1/12 hours. Just to get that out of the way. That way everything is going to be in hours and we can deal with miles per hour, so to speak, I guess. Yeah. So what we're looking at, we want to know when your speed is equal to their speed plus an additional 10 miles per hour. because you are going 10 miles per hour faster than them. So this here is one equation in kind of words, I guess. So you're going to take whatever your speed is going to be equal to their speed plus 10 miles per hour. That way you'll have the same speed because you're going 10 miles faster than they are. So their speed plus 10 is going to be your speed. Getting that right from here. Your speed is 10 miles per hour faster than their average speed. So that's coming out right from this. I don't know why I blocked it off like that. That's weird. But it's coming from that section there. You also know that your speed times your time, right? The time that you spend, I guess we're going to call this your time because grandma's going to have more time. The time that you spend driving is going to be equal to their speed times do we have that number? Your speed. No, we don't know their speed. Their speed times and this is going to be times their time in hours. I believe it's going to be times their time. So let's get these into equations. This one's not too difficult to do. You know your speed is y. So y is going to equal their speed, which is g, plus 10 miles per hour. So there's your first equation, right? You're going to take your speed is equal to grandma's speed plus 10. Right? Because your speed is 5 miles per hour, or 10 or their speed is 10 miles per hour slower. So you need to take their speed and add the other additional 10. Next we need this one, which is your speed, which is y, times your time, which is 25 minutes. We know that one. That's what we know. That's what I was looking for. We know that your time, which is 5/12, and we actually know their time too, which is at 5 minutes after. Should be equal to their speed, which is grandma, times their 5 minutes. Yep, that's looking good. So these are your two equations. You're just going to plug into each other. You'll see that this one here is already equal to y, so we can just substitute it right in. So here we get g plus 10 times 5/12 equals g times 1/12. And we're going to go ahead and multiply each of those by 12 just to get rid of it. Because I don't like the denominator. So yeah, we're going to multiply each side by 12. I don't think we want fractions, so let's get rid of fractions. If you use the decimal, you probably don't have to do this because will just be a decimal here, but I just don't want to deal with the fraction. So we are going to multiply each side by 12 just to get it out. Remember, if I do it to this side, I can do it to this side. And it won't change anything as long as I do it to both sides. And all what this is going to do is get rid of my denominators. Because this is all multiplication over here, it's just going to put a 12 in the numerator of everything while there's a 12 in the denominator, so they will cancel. So you're going to get g plus 10 times 5 is equal to g times 1, which is just g. But then we can get things together here. I'm sorry, this is getting distributed too. After you do that, so don't lose those parentheses. We'll deal with this. I mean, g times 1, you know, is just g. We'll just leave it as that. Over here, you're going to have to distribute. So 5 goes to 10, and 5 goes to g, so you're going to get 5g. I don't know why I'm going lowercase. 5g plus 10, I'm sorry, plus 50. 5 times g is 5g, 5 times 10 is 50, equals g. You're then going to get your g's together by subtracting 5g over here and subtracting 5g over here. This is going to become 50 equals 1g minus 5. I made a mistake here, because I shouldn't be getting a negative number. What did I do wrong? Did I read wrong again? 5 minutes after they leave. It's because their time isn't 5 minutes. Where is that coming from? You might have to do a rate problem here. But I gave you a really tough one to start with. Let's put a pin in this problem. Let's come back to it on Tuesday. Let me give me some time over the weekend to see what's going on. I'm missing something right here. Sometimes you got to take a step back and do it and just kind of relook at things. I'm sorry about that. This isn't making sense. This 1/12 doesn't make sense. I want to say that should be 1/2 when I did it before. Uncle, I've been visiting your home. 5 minutes after they drive away, you realize they forgot their luggage. You have to know that they drive slowly, so you get in your car and drive to catch up with it. Average speed is 10 miles an hour faster than their average speed, and you catch up to them in 25 minutes. Oh, that's because that is 1/2, because this is going to be, their time is actually 5 minutes plus the 25 minutes you took to go over, which is why I'm getting 1/2 there. So this is actually 1/2. Then we multiply that by 12. This becomes 6g. Then this is going to be 6g. So when I subtract 6g, I'm going to get 1g. So grandma's speed is 50. Yeah, I'm reading things wrong. That's my biggest mistake. It's 5 minutes after they drive away. So this is their time. So this is 5 minutes after. So we take and count 5 minutes, and we take and count the 25 minutes that it took you to drive there. And together that's half an hour. And that's why this is going to be a half. So then when you multiply by 12 here, half of 12 is 6. So it's going to become 6G. And then you're going to do everything else like we did. And you're going to get 50 miles per hour for grandma's speed. And then you're going to take it and plug it back into here, and yours is going to be 60. So here you plug it back in to your original one, so you get y equals, g is 50 plus 10, so your speed is going to be 60 miles per hour, and grandma's speed is going to be 50 miles per hour. I forgot that one little detail. But as I was doing it, I noticed things weren't making sense, so I kind of looked back on it and see where it was. But that is, they do get kind of tough and tricky, and you got to read carefully. And I was never the strongest reader, and that's why I struggle with these. But hopefully I didn't screw you guys up too much. Let's look at another one. I don't know if I can get this one up there. But again, we're going to be working on this page for a couple days. So I'm telling you to give them a try. It would be more beneficial to you if you gave them a try and came with an answer, as opposed to me just kind of going over them while you do it. So that's what I'm going to advise you to do. That was the wrong button. Copy. Let's get a whole new thing. Let's hide everything. Move off that one, and let's see if I can read this one correctly. It's been a while since I did these. Oh, this one's pretty long. Let's hope this one fits. And barely. I'll move it there. All right. So let's get this layer up here. Okay, you run an accounting business that specializes in auditing, which is verifying records, if you didn't know what that is. One of the auditors is working on the payroll records for a company with 75 employees. Some are part-time and some are full-time. After working for 3 days, your auditor tells you that the audit is completed for half of the full-time employees, but there are still 50 employee records to audit. Find out how many employees are full-time and how many are part-time. So kind of a puzzly question here. Picking out some information, you know that you're running, specializing in auditing, auditor worker on payroll. Your company has 75 employees, so the total number of employees is equal to however many full-time employees you have plus half-time employees. Or I guess, did they say half-time or part-time? I don't know, they say part-time, so we're going to say part-time. Plus part-time employees. We're going to go over here and we're going to say H equals we're going to say F equals full-time employees, and we're going to call P for part-time employees. You could have chose whatever variables you wanted, but I'm going to use F for full-time, P for part-time. So you're running a business specializing in that. You know that there are a total of 75 employees. So you know the total here is 75, just to take note of it. Some are part-time and some are full-time. So 75 equals your full-time plus your part-time. So there's your first equation. That one wasn't too bad to pull out. Let's get rid of those parentheses. So there's your first equation. After working for 3 days, your auditor tells you that the audit is completed for half the full-time employees, but there are still 50 employee records to audit. So find out how many employees are full-time and how many are part-time. So we still have 50 to audit. So after we've covered 75, the total minus what we covered, we'll write in words first. We can take the total minus what we actually covered minus what's done. So the total is 75. You have 50 of them. No. We want to get how many are done minus what's left. And that's going to equal how many are done. So we can get that number pretty easily, which is 50. We actually know that there's still, they've only done 25 records is what I'm trying to get at. And you can figure that out, right? We started with 75 records that need to be done. We did 25 of them, and now we have 50 more to do, because 75 minus 50 is 25. That's what we're getting at there. So we have however many are done. Actually, we don't need this part of our equation. We're just going to put it in there. We'll move this off to the side too, just so we're collecting information here, making sure we're reading things correctly this time. So I know this is going to be how many are done. So I know out of the ones that are done, they did, after working 3 days, your audit tells you the audit is completed for half of the full-time employees. Some are part-time, some are full-time. After working 3 days, the auditor tells you that the audit is completed for half of the full-time employees, but there are still 50 employee records to audit. Find out. I'm assuming it didn't do any of the part-time ones then. So done is equal to half the full-time. So half times the full-time. And we get P in there. We might not have P in this one. This one might actually just be kind of a substitution thing. I don't know. Let's do it and see what happens, because I'm not getting a part-time variable for this one, but we might not have it. So we know that there are 25 that are done, and that represents half the full-time people. So you can solve for full-time right here, and then just plug it into this one. So here we can solve for full-time, which isn't making sense because they had to have done plus some part-time employees there. Half the full-time plus some part-time. It has to be done that way. That makes more sense, because you can't have, if you did half of them, you can't have half of a person. So let's go with that and see what happens. We're going to solve for P for one of them. Might as well do it for this one. So we have 75 equals F plus P. You can subtract F from this side, subtract F from this side. So 75 minus however many full-time employees you have is going to equal the number of part-time employees you have. And that makes sense. You also have the equation over here. We can substitute in for P. So 25 is equal to half the full-time employees plus 75 yeah, I don't think you actually need the parentheses, minus the full-time employees. Here you can combine like terms. Half the full-time employees plus the full-time employees is 25 equals 1.5 times the full-time employees plus 75. Subtract 75, subtract 75. So I'm getting a negative number here now too. So maybe this isn't right. I'm having an off day, guys. I'm going to do the homework too. I'm going to see what I come up with. We'll compare answers on Tuesday. This isn't all your part-time, that's why. It's half your full-time plus some part-time. And I don't know how many part-time. Does it tell you that? Some are part-time and some are full-time. After working for 3 days, the auditor tells you that the audit is completed for half of the full-time employees, but there are still 50 employees on record. Maybe it is just that. If you guys have any ideas, go ahead and throw them in there. I'm going to put a pin in this one too. I'll do one more here. Let's do the next one. This one sounds easier. But give them a shot. We'll compare answers on Tuesday. Yep, that one's going over a bit. All right. You invite 80 or 56 people to your graduation party. You can afford to rent 5 tables, round or rectangular. Each costs the same. Each round table can seat 8 people, and each rectangular table can seat 12 people. How many round and rectangular tables should you rent? This one's not too bad. Here we know that we have 56 people total. So however many people are going to sit at a round table, I don't know, let's see. You can afford to rent 5 tables. So let's start with that. You can afford to rent 5 tables, round or rectangular. Let's call round tables R, because it starts with round, and let's call rectangular tables, I don't know, that also starts with, let's call it S. We'll change that to square tables in our heads, so just keep track of that. We'll call it S. You can afford to rent 5 tables, so our 5 tables have to equal however many rectangular tables plus however many, I'm sorry, round tables plus how many rectangular tables we have. So rectangular tables, or round tables plus rectangular tables have to equal 5. Each costs the same. Each table can sit 8 people, or I'm sorry, round tables can sit 8 people. So you're going to take your round and you're going to multiply by 8, and that would be how many people can sit at your round tables. And each rectangular table can hold 12, so plus 12 people that can sit at your square tables, and they have to equal your 56 people that are going. So this one, I don't know why I did it this way. Let's do 8 times your round table, just that way. So here you can solve for RS, it doesn't really matter. And there might be multiple answers to this one too. Because I mean, you could just rent all rectangular tables. But let's find a good solution here. So over here we can solve for, I don't know, I guess r. So 5 equals r plus s, subtract s from that side, subtract s. So 5 minus s equals r. You can go ahead and plug that in for r. So 8 times 5 minus s plus 12 times s equals 56. Distribute. 5 times 8 is 40, minus 8 times s is 8s, plus 12s equals 56. Negative 8 plus 12 gives you 40, and then 8 minus 12 is 4. S equals 56. Subtract 40. Subtract 40. This one's making more sense already. 4s equals 16. Divide by 4, divide by 4. You get s equals 4. So you need 4 rectangular tables. So then go ahead and plug it back into here, and you get 5 equals 4 plus, I'm sorry, 4 is s. You need 4 rectangular tables, and you need 1 round table, because minus 4 minus 4, 1 equals r. So you can do that combination. Is one possible combination for it. So there's that one. That one wasn't too difficult. Again, just round table would be 1. Rectangular would be 4. And you can double check that as well. Each round table holds 8, so there's 8 people there. And each rectangular people holds 12, so there's 48 there. And 8 plus 48 is going to give you your 56. So that one's a little easier, not as wordy as the other ones. So I'm going to leave you there. Try some. That's what I'm asking you to do. I don't expect you to get them all right. Try some, see what you can come up with. You have till Tuesday. Again, just pick 2 or 3 to try. That's all I'm asking you to do. We'll look at them more on Tuesday, but it is going to be a slow process getting to it and getting better at them. I just have issues with reading. I was never very good at reading problems or anything really. But I work through them. When it doesn't make sense, I go back and look at them. So I apologize for the second one there. I'm missing something when I'm reading that. I'll look at them too over this longer, well, I guess it's not really a long weekend. You have field day Monday, so you're not going to be having a lesson. So you got to do like push-ups or something. And I will talk to you then. So long. Bye.